Welcome to Narayan PU online classes. So in the previous episode we completed some of the important concepts. So these are basics for the chemistry. So in this today's episode we will discuss regarding about chemical reactions. What is chemical reactions? Chemical reactions are classified into how many types we will discuss in this today's episode. So what is chemical reaction? So chemical reaction is a process in which one or more substances that maybe are calling as a reactants are converted into one or more different substances, those what we are calling here products only. Simply in a chemical reaction, reactants are converted into products. Reactants are converted into what? Products only. It is a process. It is a process in which one or more substances, those what are calling here reactants, are converted into one or more different substances, those we are calling as a products. Okay, if you want to take the chemical reaction, simply we are calling as reactants. Reactants are converted into products. So chemical reaction mainly observe the conversion of reactants into what? Products only. So this is reactant. Generally reactant can be presented left hand side. Products can be presented right hand side. This arrow represents the direction of the reaction, where it moves or in which direction it moves. The reactant molecules are converted into products. We are showing this direction only. If you want to see this one, products are converted to reactants, we can write what? Reverse direction like this one. Okay? Arrow represents which one? Direction of the reaction. Generally we are calling this arrow gives rise to. Okay? Let us see one example related to this chemical reaction. So I am writing one example. We have 2H2 plus O2 gives rise to 2H2O. Clear? So 2H2 plus O2. H2 and O2 will combine to form water. Here what is the H2 and O2? H2 and O2 we are calling as a reactants and H2O we are calling as a product. Let us see one more example. We have N2 plus 3H2 reversibly gives rise to 2NH2. Okay, so you already told you left hand side what is there? Reactants are there, and right hand side what we have? Products are there. Like this we will write different types of the example. S plus O2 gives rise to what? SO2. So this is regarding about this one chemical reaction. Chemical reaction is a process in which reactant molecules are converted into products. Generally we have different types of the chemical reactions are there. The reactant molecules in a single step does not convert into products. Okay, particularly in the organic chemistry, we will see different types of the reaction intermediates. So what are those reaction intermediate means? We will study in the form of organic chemistry: carbocations, carbanions, carbenes, nitrates, and benzenes. These are called reactive intermediates. Okay, these are one of the intermediates can be formed in a chemical reaction. So this is regarding about here chemical reaction. So generally how many these chemical reactions are classified into how many types are there? We have different types. We have one is chemical combination reaction, chemical decomposition reaction, chemical displacement reaction, and double displacement reaction and neutralization reaction. Total we have how many types of reactions are there? five types of the chemical reactions are there. In this, the first one we have chemical combination reaction. Chemical combination reaction. Okay, the first one you can see chemical combination. Okay, what is this chemical combination reaction? Okay, in this reaction, and two or more elements or compounds to form a new compound, a single product or a single compound is said to be chemical combination reaction. Let us see one example we have. A plus B gives rise to what? AB. So A and B are the reactants. AB is the product when two or more different elements or compounds to form a new compound or a single compound, that is said to be what reaction we have? Chemical combination reaction. Chemical combination reaction. So what are the example we can take? I will give one example here. N2 plus 3H2 gives rise to 2NH2. Can you say this example for chemical combination? Yes, because here two or more elements are combined but form a single product, that is one product only. So this comes under what type of reaction we have? Chemical combination reaction we have. So we can write one more example. We have SO3 plus H2O. You will get one compound here, H2SO4. Clear? And you can see one more example we have. You can write with water also. 2H2 plus O2 gives rise to and 2H2O. In this all the reaction what are observing here, it will form a single product. So this comes under what type of reaction? Chemical combination reaction only. Chemical combination reaction. So the second one we have. The second one we have chemical decomposition reaction. Chemical decomposition reaction only. What is meant by decomposition reaction? A chemical compound split into two or more similar substances. A chemical compound split into two or more similar substances. That reaction is said to be what reaction? Chemical decomposition reaction. Okay, if you want to take an AB, AB is a compound only. This AB compound can be dissociated into A plus and what B. Same or in different combinations only. So a chemical compound split into two or more new simpler substances is said to be what? Chemical decomposition reaction. So generally decomposition reactions require some conditions. We have to maintain high temperature and sometimes you have to pass some electricity. Then only the decomposition reaction will be takes place only. Let us see one example. We have calcium carbonate, CaCO3. Calcium carbonate can be decomposed at high temperature. It dissociates to give CaO plus CO2 only. So this is the decomposition reaction because the calcium carbonate can be decomposed into CaO plus what? H2O. So this is comes under what reaction? Chemical decomposition reaction. Now I am taking here KClO3. What is KClO3? Means potassium chloride. Potassium chloride undergo decomposition means heating. You will get here KCl plus what? PO2. We can balance this equation. 2 KCl gives rise to 2 KCl plus what? 3 O2. So this is also an example for which one? Chemical decomposition reaction. Let us see some other examples of this decomposition reaction. If you want to take the water, okay, water we can do the electrolysis only. Water we are doing electrolysis. Okay, when if you do the electrolysis, then what are the products are formed? Means here H2 and what? O2 is formed only. So this is also comes under what reaction? This also comes under decomposition reaction. So if you want to take ammonium chloride on heating, then you will get NH3 plus what? HCl. NH3 plus what? HCl. If you want to take here sucrose, C12, H22, O11, suppose you want to heat the temperature, you will get carbon plus what? Water. Carbon plus what? Water. So all these reactions what are occurring here, a chemical compound is split into two or more different products. Okay, that reaction is comes under what? Chemical decomposition reaction. So the next reaction we have chemical displacement reaction. We discussed chemical combination and chemical decomposition, and the next one we have chemical displacement reaction. What is this chemical displacement reaction means? In a chemical reaction, more reactive element displaces the less reactive element only, or otherwise one element displaces the another element in a chemical reaction. That is said to be which one here? Chemical displacement reaction. Let us see one example. We have A plus BC is there. It is converted into AC plus B. Or you can write this one otherwise. AB plus C gives rise to what you can say here BC plus A also. Okay. In a chemical reaction, one element displaces another element from its compound. That reaction is said to be which reaction? Chemical displacement reaction. Otherwise, one more definition I told. When more reactive element displaces the less reactive element from its compound, that is also said to be what? Chemical displacement reaction. Let us see one example. We have reaction of zinc with hydrochloric acid. Zinc reaction with hydrochloric acid, it will form ZnCl2 and what? H2O. We can balance this equation. Zn plus 2 itself with rise to ZnCl2 plus H2. You can see the replacement here. Zinc replaces. Okay, which portion here? Chlorine portion from which one? HCl only. So it will form what compound? ZnCl2 and what? Cl2. It is comes under what reaction? Chemical displacement reaction only. If we take magnesium also, Mg plus 2HCl gives rise to, you can write here MgCl2 plus what? H2. MgCl2 plus what? H2. So this is also, we can say, one of the example for which one? Chemical displacement reaction. Let us see one more example we have. Br2 plus 2NaC. Now we can see Cl2 plus 2NaBr. Cl2 plus 2NaBr gives rise to, we'll say here 2NaCl plus Br. Okay, we can compare the reactivity. We'll say this is comes into what reaction means chemical displacement reaction. Okay, and the next one we have double displacement reactions. Double displacement reaction. So double displacement reaction mainly takes place between two ionic compounds only. In these two ionic compounds, there is an exchange of ions takes place. Then only the double displacement reaction will be takes place only. Okay. So suppose I am writing here AB plus CD. Then you are getting here AC plus what? BDO. Means what here? If you take the two compounds should be what you can say the ionic in nature, means they can easily split into ions. Then only there is exchanging of ion will takes place. So your exchange will takes place here. Here the exchange from A to C, and here the exchange from what? B to D, and A and C combined to form AC, and B and D combined to form what? BD. So this is a general example for which one? Double displacement reaction. A compound should be ionic. The exchanging of ions will takes place between the two components or two compounds. Then what the reaction occurs? The reaction is double displacement reaction. Let us see one example. We have silver nitrate, AgNO3. Okay, AgNO3 reaction with NaCl. Okay, AgNO3 reaction with what? NaCl. You will get AgCl plus NaPnO3. Okay, how can you say this reaction is example for double displacement means? Let us see we have AgNO3 dissociated into Ag plus and what? NO3 minus. Okay, from this you can write here Na plus and Cl minus. Na plus and what? Cl minus. This positive and negative ions, Ag plus and Cl minus combine to form AgCl, and here NO3 minus and Na plus it will combine to form which one? NaO3 only. Generally it will form a precipitate form. What is the compound is formed here? Precipitate is formed. You understood, I think? Exchanging of positive and negatively charged ion takes place between what? An ionic to ionic compounds. What is formed here? The precipitate is formed. Generally, AgCl precipitate you are getting a what type of precipitate means white precipitate we are getting out. Okay, let us see one more example we have. MgSO4 plus BaCl2. MgSO4 plus BaCl2 gives rise to BaSO4 plus MgCl2. BaSO4 plus what by MgCl2. Magnesium sulfate will combine with barium chloride, it will form barium sulfate is formed a precipitate. It is also comes under what reaction means double displacement reaction. So the next chemical reaction we have neutralization reaction. What is meant by neutralization reaction means an acid and base combine to form salt and water, that we are calling as a neutralization reaction. In the previous episode already discussed regarding about the salts, how the salts are formed we discussed. Okay, but here we are talking about neutralization reaction. Okay, what is neutralization reaction? When acid and base combined or undergo chemical reaction to form salt and water. To form salt and water. That reaction we are calling as what? Neutralization reaction only. Let us see one example we have. Sodium hydroxide with hydrochloric acid. Okay, sodium hydroxide will combine with hydrochloric acid HCl. It will form NaCl plus H2O only. So this NaCl is what? Salt. They will form what here? Water only. So NaO which is what? Acid. Sorry, base. And HCl is what? Acid. Both are combined to form what? Salt and water. So this is comes under what reaction means here? Neutralization reaction. If you want a potassium hydroxide, potassium hydroxide will combine with sulfuric acid. You will get here K2SO4 plus H2O. Okay, these 2 moles of this one. So this is a base. This is what? Acid, sulfuric acid. It will form what? Potassium sulfate with water. If you want to take calcium hydroxide, calcium hydroxide will combine with H2SO4. It will form CaSO4 plus what? 2H2O. Here calcium sulfate is salt, and along with what is formed here? Water is formed. These are examples for which one? Neutralization reactions. So this is regarding about types of chemical reactions. So the next concept is we have variable valency. Already the previous episode we discussed valency. What is valency? Valence is a combined capacity of an element. But what is the difference between variable valency and valency? Variable valency means if an element shows more than one valency in its compounds. If an element shows more than one valency in its compounds, that is said to be what? Variable valency. Element shows more than one valency in its compounds. An element shows more than one valence in its compound is said to be what? Variable valence. So let us see one example we have. FeCl2 and FeCl3. Okay, Fe and Cl2, FeCl3. Elements are same one. Here what is the valency of iron? The valency of iron is here 2 here. Here the valency of iron is how much? 3 1. Same element, but shows what? More than one valence in compounds. This is called what? Variable valence. Okay. So generally what type of elements generally exhibits this variable balance means here, especially D block elements. D block elements, you know, periodic table having 4 blocks, S block, P block, and D block, F block. S block is there, P block that side, middle what we have, D block, down we have F block. So the elements which comes under D block elements, majority of the element will show what type of the balance means here, variable balance, variable balance. Suppose we are observing here 2 balances is there. Okay, so this is can we say this is the lower valency, and this what you can say higher valence. Lower valence is there, higher valence is there. Lower valence is there, we have to add suffix OUS. Okay, if higher valence is there, we can add here suffix what? Equal. OUS and what? Equal. OUS for which one? Lower valency. Okay, higher valence is there, we have to use one. Clear? So we will discuss some of the elements which shows variable valences, how we can write the names of the compound. Okay, majority of the names of the compound we are using. Okay, what we can say here, if iron is there. Okay, FeCl is there, FeCl is there. Ferrous chloride, ferric chloride. Ferrous chloride and what? Ferric chloride. Ferrous, FeCl2, because it is a lower valency, and P is a higher valency, what we can add? Equally, ferrous and ferric we can use. Okay, let us see one example. We have to draw a small table related to this variable valence. Okay, element I am writing here. Element, and we have lower valency, and one more we have higher valence. Higher valency. Okay, suppose the element is we have to take the iron and copper, silver, tin, and lead we are writing here. Okay, and how we can write the numbers and you can see that element. First I am writing here iron. Okay, iron, the possibilities we have FeCl2 and one more we have FeCl2. So FeCl2, what is the name here? Ferrous chloride, and what we have? Ferric chloride. Ferric chloride. Here, if you want to take the copper, we have. So copper symbol Cu, here iron symbol we have Fe, and copper I am writing here Cu2Cl2. And here I am writing here CuCl2. Copper we are calling as cuprous. Okay, cuprous chloride. Cuprous chloride. And here what we have here? Cupric chloride. Okay. And third one you can see here tin. Sn. I am writing here SnCl2 and I am writing here SnCl4. So tin means we are calling as stannous chloride. Stannous chloride, and we have here stannic chloride. Stannous chloride and stannic chloride. Okay, and you can take one more. We have mercury. Mercury we are calling here Hg, and you can see here Hg2Cl2, and here we have HgCl2. Okay, this is mercurous chloride. Mercurous chloride, and this is mercuric chloride. Mercuric chloride. Clear? You can take this one. Lead also. Lead we have Pb. We can write here PbCl2, and we can write here PbCl4, flumbus chloride. Okay, this is plumbic chloride. So maximum using here Latin words only. Clear? So we can see all these example. The element shows more than one valency. If you can observe a compound like this, whether it is a higher valency or lower valency, you can observe. We can add the words here OUS, us, and ICE. We can add on. We can take this silver also, argentous chloride or argentic chloride only. This is regarding about which one? Variable valence. About here element to lower valence and what na? Higher valency. So all these elements, iron, copper, tin, mercury, lead, or silver, all these comes under what exam? What element? Those are D block elements only. Which element mainly shows this variable valency? D block elements only shows variable valence. And now we can see the valency here. Here FeCl2, iron combined with chlorines. How many? 2. So valence is 2. Here iron combined with how many chlorines? We have 3. So the higher valence is how much? 3. Cuprous chloride. 2 copper atoms combined with 2 chlorine atom. So what is the combining capacity of each copper? It is 1 only. It is lower valency. CuCl2. Copper combined with 2 chlorine. So valence is how much here? 2. Here SnCl2. We have 2. SnCl4. So this is lower valency. This is what? Higher valency. And G2Cl2. Each mercury combined with 1 chlorine only. So here 1 and here 2. This is mercurous chloride. This is mercury chloride. Here the valence is 2. That is lower valency. Here the valence is 4. This is what? Higher valency. This is flumbus chloride and what? Plumbic chloride. So next concept we have valency shell only. Before identifying this valency shell, you have to know what is the shell. What is shell? Let us see this one. This is the center of the part of the atom. This is called the nucleus only. And here we have electrons are revolving around the nucleus only. So this generally, what is meant by shell? Okay, electrons are revolving around the nucleus in a circular paths. The circular paths we are calling here shell or orbit. Shell or what? Orbit. So this center of the atom, you can say this is the center of the part only. So electrons are revolving in a different circular path. So these part what we are calling here shells only. Clear? What is meant by valency shell? So what is meant by valency shell means the last shell of the orbit. The last shell of the orbit is called as a valency shell only. So we have different shells is there. Here we have one shell, and here one shell here. Here we have one shell only. So this is the last shell only. So the last shell of the orbit we are calling as a what shell? Valency shell only is denoted by N. Sometimes we are calling it is a ultimate shell also. What are you calling? Ultimate shell. The cell just before the valency shell. The cell just before the valency shell we are calling as a penultimate shell. The shell just before the valency shell is calling as a penultimate shell. It is denoted by N minus 1 only. And the shell just before the penultimate shell. So this is valency shell, this is penultimate shell, and before the penultimate shell, what the shell we have means anti-penultimate shell. Anti-penultimate shell. It is represented by, generally we are using M minus 2 only. See here, last shell means valency shell. Before the valency shell is penultimate shell, and before the penultimate shell is what shell we have? Anti-penultimate shell only. So what is the use of this concept means we have to identify the valency electrons in a given element only. If the element is given, they are asking how many valence electrons can be present in this element means we can easily identify by knowing this definitions only. Let us see one example we have. Okay, sodium. Okay, how many number of electrons, valence electrons can be present in sodium atom only? Clear? If you know the sodium atom atomic number of the sodium is 11 only. Clear? Already you know writing of electronic configurations. If you don't know, we'll discuss in next episode how to write the electronic configuration. Just I'm writing like this here: 1s2, 2s2, 2p6, and 3s1 now. 1s2, 2s2, 2p6, and what? 3s1 we have. So this is what here. This is the electronic configuration of which element means sodium element. So from this element we have to find out here the sodium elements contains how many valence electrons. So this is the one shell now, and this is the next shell, and this is the next shell now. This is the first shell, this is the second shell, this is the third shell. Third shell is what shell? It is a valence shell only. So 3s1 is what shell? 3s1 is a valence shell. It contains how many electron? It contains only one electron in the valence shell. Clear? So this way we can identify the valence electron. Or sometimes you are writing here 281 also. Okay, 281 also you can see. So this is the first shell, this is the second shell, this is the last shell. Having how many electrons here? One electron we have one. So like this you can identify how many valence electrons can be present in a given element by comparing with this definition.